after 30 seconds. అవును స్ట్రీమింగ్కి వెళ్ళిపోయింది స్టార్ట్ చేసాను సార్ చెప్పాలి అవును 11కే స్టార్ట్ అవుద్ది యూట్యూబ్
Good morning to all. Myself, Dr. S.K. Aminabi, Coordinator, Head Department of Pharmacology in Leading Institute of Pharmaceutical Sciences, Gundavaleru, Andhra Pradesh. It's my privilege to invite you all for the second day for the e-conference on alternatives to animal experimentation in pharmacology, organized by Department of Pharmacology, Leading Institute of Pharmaceutical Sciences, Gundavaleru, in association with Acharya Nagarjuna University College of Pharmaceutical Sciences, Nagarjuna Nagar. Now I request the convener, Professor A. Lakshman Rao sir, to speak few words about the second day.
Thank you, Amina Garu. Eminent speaker of today's session, Senior Researcher, Dr. Pradeep Chakraborty Garu, Senior Scientist, Department of Assisted Reproduction, Indian Council for Medical Research, Institute of Reproductive Medicine, Kolkata, and my colleague and coordinator for the e-conference, Dr. Sheikh Aminabi Garu, Head Department of Pharmacology, participants from various colleges. A very good morning to one and all for the second day of National E-Conference on Alternative to Animal Experimentation in Pharmacology. Today's resource person, Dr. Pradeep Chakraborty, will deliver the lecture on pubertal metabolic changes. Part 2, adolescent polycystic ovary syndrome and unexpected pregnancy loss. And today's speaker is having a vast knowledge, experience, and expertise in the area of reproductive medicine. And now I hand over the session to Dr. Sheikh Aminabi, coordinator for the today's e-conference, to introduce the today's speaker, Dr. Pradeep Chakraborty Garu, to the participants. Over to Aminabi.
Thank you, sir. Thank you so much. It's my privilege to introduce today's speaker, Dr. Pradeep Chakraborty sir, Senior Scientist, Department of Assisted Reproduction, ICMR, Institute of Reproductive Medicine, Kolkata. Sir did his PhD in biochemistry in 2012 with a special reference to Reproductive Endocrinology, Calcutta University, Institute of Reproductive Medicine, Calcutta, India. Adjudged as an international reviewer in formulating controlled ovarian stimulation guidelines of European Society of Human Reproduction and Fertility in 2019. Sir was awarded as amongst the best in the clinical science topic by European Society of Human Reproductive and Fertility in 2018 at 34th annual meeting at Spain, adjudged as an international reviewer in formulating recurrent pregnancy loss guidelines of European Society of Human Reproduction and Fertility Committee in 2017. Awarded with prestigious honorary membership by American Society of Reproductive Medicine in 2013. Received Young Scientist Award from Department of Science and Technology, Government of India in the year 2014. Published more than 40 international articles in reproductive medicine. Research interests are polycystic ovarian syndrome, recurrent pregnancy loss, with special reference to hypermastemia endometriosis. With this brief introduction, now I invite the speaker, Dr. Pradeep Chakraborty sir, to share the to proceed the session. Over to Pradeep sir.
Thank you, Professor Aminabi, for such a nice and kind introduction. And first of all, good morning to all the distinguished faculties and my dear students. And especially, I would like to thank Professor Lakshman Rao who have invited me on this platform for giving today's lecture on pubertal, metabolic, and endocrine changes in polycystic ovary syndrome, which is a burning topic in among the reproductive aged women in our society. When I have started my PhD career long back, then the incidence of PCO was around 5 to 10%. But nowadays in the clinic, the incidence has increased up to 15%, which is a huge number. And sometimes the immediate fate of polycystic ovary is a miscarriage, which is of various types, and I will discuss it later on. Next, please. My title slide, please.
Yes. Yes, sir. Wait a second.
Yes. Can it be made larger?
Yes, sir. I'm doing.
Nice. So, next slide. Next slide one. Yes. So, let us discuss about the origin of PCO and why this is so important. The origin or the genesis of this disease practically starts from puberty. Now, what is puberty? Puberty, in my words, it is a transitional period or a transitional phase between the immaturity of childhood and the maturity of adulthood. And it is this particular age or the phase through which profound physical and physiological changes occur in a child to an adolescent and thereafter to a mature adult woman. However, as I have previously told that in recent times, much about the origin of PCO have been witnessed all over the world and among all gynecological
Comments
societies.
already changed.
Next one,
Comments
please.
are-
Next,
comments
please.
are closed. Yes, sir.
Yes. When a adolescent woman or a adult mature woman comes to a reproductive clinic, then usually she comes with two problems. One is the irregular cycle, be it amenorrhea or dysmenorrhea or dysovulation, and the second one is the PCO related obesity or the type 2 mellitus. Now, for a clinician or a reproductive endocrinologist, the challenge is to understand and find the ways to solve the problem and from where does it occur. Next. Next. We know that insulin is the major growth hormone in our body, and a temporary increase in serum insulin at this point of time of puberty leads to transient hyperinsulinemia. However, one should keep in mind that this metabolic change is reversible. But if this change continues to persist, then it may lead to PCO in adolescence and in adult life. So let us quickly brush through that what are the hormones usually comes at the adolescent period. These are all trophic hormones which are synthesized and released during puberty for growth. Growth is a very important term or a terminology during the adolescent period, and it encompasses all the hormones like somatotropic, gonadotropic, adrenocorticotropic, and thyrotropic. Next, please. Now, physiological hyperinsulinemia. How does it happen? With the onset of puberty, there is increased synthesis and release of growth hormone. Increased growth hormone will lead to lipolysis, thereby resulting an increase of free fatty acid. We all know that free fatty acid has a higher metabolic activity over glucose. So it will compete with glucose for oxidation, and the result is decreased glucose utilization. And ultimately, the development of compensatory hyperinsulinemia. The reproductive endocrinologists term this as pubertal physiological hyperinsulinemia. Next, please. This physiological hyperinsulinemia slowly increases the glucose utilization at target tissue because more and more insulin is coming into the act to counter the free fatty acid and result the decreased free fatty acid oxidation. So it counteracts the lipolytic effect of growth hormone. Next one. However, this physiological hyperinsulinemia is essential because it leads to the protein anabolic effect and growth which an adolescent girl is about to have. Next one. We should keep in mind that both the increase in growth hormone as well as the serum insulin levels are temporary in normal adolescence, and they should be totally reversible after the growth spurt has been achieved. Next. If hyperinsulinemia persists, okay, if hyperinsulinemia persists, obesity will increase, which is prone to develop through PCO. Now coming to the next picture, which is of two-cell two-gonadotropin theory. Now everyone should understand this particular slide very, very carefully because this is the basis of the whole story. Why this is two cells? Because two cells are there. One is the theca and another is granulosa. And why two gonadotropin? Because two gonadotropins are there. One is LH and another is FSH. So cholesterol comes from the liver, goes to the side chain cleavage system inside the theca, ultimately forms androstenedione, which is converted to testosterone, which is another androgen, or the chief androgen in a female body, and then that particular testosterone has got two fates. One is aromatized inside the granulosa cell via the synergistic effect of FSH from the hypothalamus and an aromatase enzyme, and the second is the conversion of excess testosterone to dihydrotestosterone, which is a non-aromatizable form. And if DHT forms dihydrotestosterone, then it cannot move back to testosterone, its original form, and it will create all types of problems like hirsutism and so on, which I will discuss it later. Next. So, with this brief overview, let us come to what is polycystic ovary syndrome. Polycystic ovary syndrome or PCO is the most common form of dysovulatory infertility associated with androgen excess, perhaps occurring in 5 to 10% of the reproductive aged women, which now move to another 15%. So a woman is considered as polycystic. Next one. A woman is next one, please. A woman is considered as polycystic if she has any of two of the three of the following features. Previous one, please. Previous one, please. The polycystic. Yes. No. The previous one, please. The polycystic ovary syndrome slide. Yes, this is the one. So a woman is considered as polycystic if she displays any two of the following three according to the Rotterdam Consensus definition of Eschle Committee in 2003. What it says that a bilateral polycystic ovaries on USG, or oligo or anovulation, or clinical evidence or biochemical evidence of hyperandrogenism. So what is this? Clinical is what? It is called hirsutism or acne. Hirsutism is what? Hirsutism is that females does not have beard, but because of that excess DHT, they usually form beard or usually develop acne. Huh. And that is the clinical evidence. And biochemical evidence is simple from the serum itself. Increase of serum androgen, increase of serum testosterone. Now, this definition is revised time and again via the Androgen Access Society or the PCO development group in 2006 and then 2014, 15. But everybody said the same thing, that the basis of formation of PCO is hyperandrogenism. Next one. So the basic defect is hyperandrogenicity. So the next question is, why hyperandrogenicity? Multiple factors are involved. One is the associated abnormalities, what we usually say, that the hyperprolactinemia or increased of adrenocortical hyperactivity forming adrenal androgen like DHEAS. But another is the hypothyroidism leading to decreased sex hormone binding globulin and consequently increase of androgen. And other than these, the prime factor, the prima motor, is the elevated LH and excess of insulin leading to excess of IGF-1. Next slide. Now, so coming one by one, how and why LH is elevated? It is simply written over there that there is a genetic hyperactivity of LH pulse generator in the hypothalamus, and we all know that LH increases in a pulsatile fashion. That is, it increases both in the frequency and as well as in the amplitude. And unopposed action of LH because of negative feedback of progesterone on the ovaries simultaneously with positive feedback effects of chronic estrogen secretion is associated with the disorder. So net effect is LH mediated fetal androgen excess. Next slide. Hyperinsulinemia. Is hyperinsulinemia what that did? That insulin and IGF-1 is chemically and structurally similar, and if more of insulin, then usually insulin mimics the IGF-1 receptor at the theca cell, and then the androstenedione or testosterone, that is that same androgen, is formed, and simultaneously it also inhibits the production of SHBG, and ultimately the result is again increase of free testosterone, and thus the aromatizable form, the free estradiol increases. Next one. Now this is a summary that what is the insulin effect on polycystic ovary. There are three ways. One is the insulin secretion resulting in exaggerated reactivity post glucose stimulation, because there is a defect in the VNTR regulatory site, which around what the report says, around 50% of the PCO women have that, especially those women who are hyperinsulinemic and insulin resistant. And the other is termed as the insulin resistance. And why is that so? Because in normal, the insulin has a tyrosine kinase phosphorylation. If you study the molecular mechanism of insulin, then you will see that when the insulin hormone is binding to the beta subunit, then there is a tyrosine kinase phosphorylation takes place, which triggers the downstream signaling. But here, in case of the insulin resistance, in case of tyrosine kinase phosphorylation, a serine phosphorylation takes place, and the result is insulin resistance. And the third one is decreased insulin clearance or decreased hepatic degradation. Next one, please. All the summation is hyperinsulinemia, and over which, if the particular girl or the woman is obese, then it has got its stimulatory effect on hyperinsulinemia, so that the insulin will increase more and more. Yes, next. Now, the path from hyperinsulinemia to hyperandrogenicity. I have discussed it previously that hyperinsulinemia triggers the LH release and decrease in SHBG and decrease in IGF-BP1. That is insulin growth factor binding protein 1. Decreased SHBG will lead to hyperandrogenemia. More LH release will lead to hyperandrogenemia. Decreased insulin growth factor binding protein 1 will lead to increase of free insulin growth factor and again to hyperandrogenemia. Now, the summation effect is when the hyperandrogenic milieu is forming, it is giving three results. One, menstrual irregularity, be it in the form of dysovulation or dysmenorrhea or anovulation. The other is hirsutism, which is calculated by the Ferriman-Galway index, and the third is the stunted growth of follicles, thereby resulting a reduced fertility. And from the other axis, that is hyperinsulinemia, two things develop. One is hypertension and the other is dyslipidemia. That is all the metabolic activities. Next slide. Now, this is a beautiful flow chart what I have designed for you, that how hyperandrogenicity causes anovulation and enlarged ovary. Till now, I am discussing that the main culprit of PCO is hyperandrogenicity. So hyperandrogenicity normally means it is excess of androgen. So excess of androgen, we can divide it into two parts. One is the aromatizable form, aromatizable androgen, that is the testosterone, and another the peripheral conversion of estrogen. And another which I have not mentioned here is the DHT, dihydrotestosterone, the non-aromatizable form. Now from the aromatizable androgen, excess estrogen form numerous stunted follicles, because whenever androgen milieu is going up, it will give a negative feedback on the follicle stimulating hormone. Please note the name, follicle stimulating hormone. That is from the diameter of follicle will start from 1 millimeter to 2 millimeter to 4 millimeter, and then ultimately slowly it will go on and ultimately will ovulate. And when the hyperandrogenism will develop, the negative influence of that free testosterone will restrict the follicular growth, and the result is numerous stunted follicles. From these two lines, we can see that there will be a formation of static hypoestrogenism, which gives a positive feedback on hypothalamus, ultimately giving a tonic elevation in GnRH, resulting either low FSH or a tonic elevated LH, that is no LH site. And since there is low FSH, follicles will grow but do not reach maturity. So numerous stunted, incompetent follicles we will find on the USG of a polycystic ovary and women. And if we see this particular USG, I have not included the diagram over here, but you can imagine it that the polycystic ovarian USG, a typical polycystic ovarian USG will be somewhat a necklace-like pattern. The cysts are will be arranged around the cortex in a necklace-like pattern, just like a woman's necklace. Next slide, please. So the summary of pathophysiology is what? That PCO is a condition that originates possibly at the time of puberty due to the interplay of follicular maturation arrays, which leads to an or dysovulation. The major culprit is hyperandrogenism, and obesity and the excess of ovarian androgen production, which is around 50% in all PCO women, is due to hyperinsulinemia. And of that women, the insulin resistant is seen in about 40%, or the glucose intolerance or type 2 diabetes in about 31%. Next one. Next. So, a woman with PCO has two. Nah, keep that slide. Keep that slide. Previous one. Previous one, please. Yes. So a woman with PCO have two particular fates. One is reproductive and another is metabolic. And naturally, the reproductive fate sometimes is associated with miscarriage, which is a very big burden to any woman's reproductive life. And the metabolic fate usually encompasses the insulin resistance or obesity or hyperhomocysteinemia, etc., according to their ethnic variations. Today, I will discuss about the reproductive fate and the miscarriage. Next slide, please. Yes. Now, what is miscarriage? Till 2017, when we have formulated, excuse me, yes,
Yes, sir.
So in till 2017 or 2016, I forgot, when we were formulating the recurrent pregnancy loss guidelines. Till then, all they are saying that a recurrent terminology should be given to that particular subtype of women who have undergone three consecutive losses, three or more than three consecutive losses of clinically recognized pregnancies in less than 20 weeks of gestation. But in 2017 onwards, we started telling that no, greater than 3 or 3 will take much time for the clinicians to treat this recurrent pregnancy. So we have stick that particular guideline to 2. So next one, please. Be it the anatomical distance, yes. So be it previous slide.
Yes, sir.
Yes. So be it the what are the causes? So be it the anatomical disturbances or uterine structural anomalies or maternal thrombophilic disorders or thrombophilic defects or antiphospholipid anti-syndrome, all these encompasses about 50% of the causes for miscarriage, and in about other 50% the cause remains unknown. So what is the cause? What is the possible cause for the other 50%? Myself and many other scientists from different parts of the world tells that inadequate placental blood flow and thrombosis have been suggested as contributing causes of this subgroup. And what are the causes for inadequate placental blood flow and thrombosis? Is that one is genetic predisposition to thrombosis, and another is increase in serum homocysteine levels termed as hyperhomocysteinemia, or a combination of these two causes. Next. So pregnancy loss in PCO with reference to hyperinsulinemia. What is the importance of hyperinsulinemia in pregnancy loss? Association of RPL in PCO is more than common, as I am telling it from the first slide itself. And the high prevalence of hyperinsulinemia in PCO has been proposed as a pathway for the effect on obesity on some reproductive abnormalities. If you can remember or recall my slides, then you will see that I was showing some arrows that obesity is giving some stimulatory effect on hyperinsulinemia. And more a girl is obese or more a female individual is obese, then she is more prone to miscarriage. And why she will be obese? If she is hyperinsulinemic, she will be obese, or if she is obese, then she will be hyperinsulinemic. This is true for vice versa. And hyperinsulinemia adversely affects the pre-implantation environment by decreasing the expression of all those molecules named glycolidine or IGF-1 binding protein, and similarly IGF-1, etc. Next slide. Now, this is a very interesting thing, the emergence of hyperhomocysteinemia. It all started from the year of 1961, I think, when Macaulay from Uruguay, yes, no, sorry, Macaulay from Belgium, he told that homocysteine is a molecule which forms the cardiovascular thrombus in the cardiovascular vessels or the cardiac vessels. And then in the era of 90s, a group led by Vijay Ratne in Sri Lanka, they started cultivating about this homocysteine metabolism, and slowly a thing erupted in the whole world that what is homocysteine, and a homocysteine day also started to occur sometimes in November. Vijay told that hyperhomocysteinemia is very common in this part of the world, and from 2005 or 6 onwards, I started my digging with hyperhomocysteinemia, and I found that 62% of, or greater than 62% of PCOS women in India have hyperhomocysteinemia or are hyperhomocysteinic, being they are polycystic ovary or non-polycystic ovary. And there is a close association between hyperhomocysteinemia and hyperinsulinemia. Why? Because insulin inhibits the downstream catabolism of homocysteine metabolism at cystathioin beta synthase enzyme. And if more the inhibition, that is, if hyperinsulinemia occurs, more will be the inhibition, and then homocysteine accumulation will be more. If homocysteine accumulation will be more, then other vitamins will get throttled, like vitamin B6 or vitamin B12, who are acting as the cofactors. And then the immediate second one, the second cycle, that is the folic acid cycle, the one carbon pool, which we all have studied in the biochemistry, that will get throttled, thus downregulating the MTHFR enzyme, that is the methylene tetrahydrofolate reductase. Next one, please. So, a mild to moderate hyperhomocysteinemia will increase the risk of placental thrombosis. Many scientists, including Nelson and Trier, whom I have cited, some of my papers, then Vijay Ratne, all said that the increased risk of placental thrombosis is there, and the prime factor for this is the elevated plasminogen activator inhibitor 1, which will lead to the decreased response to endovasodilation, ultimately resulting vascular endothelial damage and thrombosis. But there is no specific cutoff limit to define hyperhomocysteinemia, because it has a huge ethnic variation. The individual residing in India has got a different homocysteine level if she is termed as hyperhomocysteinemia, and an individual residing in UK or US has another homocysteine level. However, greater than 12 micromole per liter in India in pregnant individuals considered to be borderline elevated. Next slide. Now, this is another thing. Importance of hyperhomocysteinemia in pregnancy loss. Increased placental oxidative stress has been proposed as a positive factor for the miscarriage. You should see this particular slide very carefully and follow all those diagrams which I have tried to draw. The reduced placental perfusion seen under these circumstances create changes in the placental microenvironment through defective trophoblast invasion and intermittency of arterial blood flow, causing a reduced remodeling of the maternal spiral artery. Now, the cause of this reduced maternal spiral modeling and the oxidative stress is not purely of hypoxic alone, because it's more of vascular, because there is a reduced maternal spiral modeling, or you can say that is as vasoconstriction. And along with this, there is trophoblast apoptosis is also there by modulating some of the key apoptosis inducing factors like BAX, PCL2, P53, MAP kinase, etc., etc. Next one. Next one, please.
Yes, sir.
Now, I won't discuss my everything, my other papers here, just to give it in a nutshell that hyperinsulinemia aggravates hyperhomocysteinemia and it causes pregnancy wastage through specific mechanisms. One of my papers states. Another, that hyperhomocysteinemia has a greater association with recurrent pregnancy loss over insulin resistance independent of PCO or non-PCO cohort. I think this is clear to everybody that hyperhomocysteinemia has a greater association with recurrent pregnancy loss over insulin resistance. And increased thrombosis caused by hyperhomocysteinemia resulting microthrombi formation in the vessel bed of the placenta can impair sustained placental function, thereby leading to pregnancy wastage. Next slide. So, what is this endoplasmic reticulum stress to mitochondria and why this is I am discussing here? It's because that hyperhomocysteinemia adversely affects pre-implantation environment by decreasing expression of those adhesion molecules like E-cadherin and IGF binding protein 2, thus inhibiting the endometrial immune response of the embryo. We should remember that the one proposed mechanism for compromised oocyte quality and poor reproductive outcome is altered mitochondrial activity at the oocyte stage. And the maturation failure and arrested cell division are linked to defects in the mitochondria dependent bioenergetic capacity of the oocytes. ATP levels increase during oocyte maturation, and oocytes with higher ATP have greater fertilization and embryo developmental rates than those with lower ATP levels. Next slide. Next slide, please. No, the previous one. The previous one. Yes. Okay. And when all these ATP levels are increasing, and we are going to deal with some experiments in the mouse or rat, we should also remember the reproductive performance of the mouse embryo or the rat embryo at each and every stage. We know that the tropoectoderm differentiation of a mouse embryo starts from the 8-cell stage, and these adhesion molecules like E-cadherin plays a role in the communication between embryo and endometrium crosstalk, mediating the effects of estrogen and progesterone on the oocytes. Next slide. So, to investigate the effects of maternal hyperhomocysteinemia on embryo quality and injury on gene expression in mice, we designed our primary study like this. We have selected some control animals, control control bulbsy mice and
నేను చూడడానికి
experimental.
కుదరదు మేడం అంటే స్క్రీన్
Pardon? Control bulbsy mice and experimental bulbsy mice, and the experimental set was gathered by this homocysteine and on cultured to day 5 selected expanded blastocysts, and we have estimated the mitochondrial membrane potential and some particular stress and apoptosis. Next one. Now, as we are gathering homocysteine, and so it will increase, that was evident, and so it was, showing a significant increase over to that of the control. Here. Now, in order to confirm the ovarian response of hyperhomocysteinemia after PNSG-ACG regimen, we and the response to gonadotropin was evaluated with respect to number of ovulated eggs per stimulated mice, which showed a significant increase in the control set, thereby a decrease in the treated set. Imaging of in vitro fertilized oocyte at different stages like 2, 4, 8 with compacted morula and blastocyst in the control group, it cannot be. I want it a bit more. The slide is bit. Hello.
యా సార్ ఓకే సార్
It's okay. This imaging gives a result that the homocysteine treatment resulted a fragmented 4-cell embryo, and then we shifted to the JC1 staining, and the specificity of mitochondrial staining by JC1 was verified through FCCP treatment of stained embryos and resulting in marked decreases of the the RITC stain. The control set reveals crossover of the dye over mitochondrial membrane, and the staining is punctate. We also averaged per embryo, and the average among this embryo tells a slightly decreased fashion in the hyperhomocysteinemic set of the decreased fluorescence of JC1 only at 4-cell stage. Next one.
సో కెన్ ఐ గో ఫర్ నెక్స్ట్ వన్
Yes. Yes.
ఇట్ ఈస్ ఓకే సార్
No. The previous one. The previous one.
Okay.
The previous one. The previous one.
yes sir
Yes. Actually, I am unable to see the complete slide.
I will set it. One second, sir. Now it is okay, sir.
Practically the same. Okay, because this last graph is showing otherwise. Okay, it's okay. That's nice. That's nice.
Wait a second.
Nice. Yes.
Okay, sir.
Thank you. Now I am talking about this figure, because given the abnormal morphology of mitochondria we reasoned that they would not likely be functional enough, because already we have seen that the JC1 staining is not good here because of the JC1 staining is not good here because of the damaged embryo of the hyperhomocysteinemic set, and also the staining is low at the foresal embryo. So how can be the metabolic demands be okay? One is for the ATP content and another is for the citrate content. However, we saw that the ATP content is practically similar among the control and the homocysteine gavage group, but the citrate content is significantly decreased, suggesting that there is a mitochondrial stress without significant compromise of the oocyte metabolism. Next slide.
Yes.
Now, these are the gene expression assessments at embryonic level. Well, those are the standard apoptotic gene like BCL2, BAX, P53 caspase 3, which all increased excepting the BCL2, which is an anti-apoptotic gene, and the other are the stress markers like ATF4, HSP70, GAT45, which all increased. But all the addition molecules, excepting the E-cadherin, they don't decrease in a remarkable fashion. Now, coming to the last slide of this one. Next one.
Yes, sir.
Yes. So, conclusively, the results herein show that the homocysteine-induced stress and growth arrest in oocytes involve more than one crosstalk at the genetic level, and the old school relation between homocysteine and the oxidative stress cues towards an association with apoptosis as observed in our study, because we have already demonstrated all those increase in apoptotic genes. The two cell state is at the time of the activation of the genome, here the mouse embryonic genome, and it could also possibly increase the transient increase in the mitochondrial membrane potential. But for the homocysteine treatment, the mitochondrial membrane potential decreased and it activates all other estrogen the endoplasmic receptor stress genes via the activation of effector caspase like caspase 3, a decrease in the E-cadherin, and in the activation of other stress genes like ATF4, HSP70, GAT45, etc., ultimately resulting in impaired development and implantation, thus resulting in embryonic damage. Hence, a more complete array of genes is warranted in future to develop the potential signaling pathway through which the homocysteine can cause this type of miscarriage. Next. Next slide, please. Yes. Now, since we were okay. Now, since we were dealing with all these preeclamptic genes and molecules, we thought that a microarray approach will be apt in this context. And the genes and pathways derived from microarray analysis are diverse, and even occasionally they are not univocal. And some of them are saying that yes, that gene is responsible, and some of the other is saying, okay, yes, that gene is responsible. Because till now, only 13 microarray studies have investigated placental gene expression, and in pregnancy loss, only 6 studies have investigated global gene expression. But however, except for leptin and its the FMS-related kinase 1, the receptor SFLT1, most studies reported inconsistent list of genes with no definite signaling pathway for the miscarriage. Next slide. So this is the in vivo module for this study. What we did, that we took a pregnant rat of 50 to 55 day old and evaluated for the histology of placenta, magnitude of hyperhomocysteinemia, placental gene expression by microarray, and whatever result we got, we again reconfirm it by QRT-PCR and immunohistochemistry. Next slide, one. Yes. Now this is the placental this is the placental pathology what we got. You can see that this is the control placenta and this is the homocysteine treated placenta. And in the homocysteine treated placenta, you can see that there is the absorbed fetus on the left uterine horn. Next one, and there is a vascular fetus, and here you can see that there is a dark placenta over here which is showing possible oxidative damage and suspected fetal thrombosis in compare to the freshly vascularized placenta in the control tissue. Next. Yes, this is the suspected fetal thrombosis slide, and since we were gauging homocysteine, we just measured the amount of homocysteine which is significantly higher than the control set. Next one. The placental histology documented a clear presence of thrombus in the study group, and moreover, the histological observation showed hemorrhage and atrophy at the junctional zone in the homocysteine treated group. And I can remember that this is not yet that I can remember that it is approximately 50% of our rats show this type of placental histology with hemorrhage and atrophy. And notably, you should remember that those placentas were dark, showing in the treated set, showing possible oxidative damage or inflammation. Next one. These are the microarray results, a volcano plot and the scatter plot, comparing the gene expression among the cases and controls against fold change differences, and the expression was measured for about 23,000 genes represented in this asymmetric platform, and the placental expression of 16,700 genes for which information was available for at least 80% of cases and 80% of controls were further analyzed. A total of 1,000 and about 1,600 genes were differentially regulated in student t-test comparison. Next one. Yes, this is 1,634. So those differentiated genes were a big number, and we cannot deal with such a huge number of genes. So we selected only those genes who give a fold change over 2.5 or at least over 2, and those are the genes which we got. And of these, these are the main genes in our to my right, and for you it will be to your left, because these will be the main genes, and of these expression of 67 genes, 61 are upregulated and the rest are downregulated, and they had an absolute change difference of greater than 2.5 or had a false discovery rate, that FDR we usually call false discovery rate, and out less than 10%. Next slide. Next slide. This is the heat map. The heat map shows correlation of the samples and selected differentially expressed genes, resulting in the hierarchical clustering of the genes in most cases. Next one. This is what we call that ingenuity pathway analysis, and this usually gives 2 or more types of networks and gives a network score. Here, one the network score is 32 and another is 30. We have usually some 6 or 7 networks, but I took only the 2 highest network scores, the 32 and 30, and of these, you can see only that there are 2 principal molecules. One is the TGF beta and other is the leptin, and they are connecting to the various other principal molecules which I have shown in the previous chart, and all those are marked in red. Next one. Next one, please. Yes. And these are the focused list of differentially expressed genes and pathways. If you can enlarge it enough, then you can see that what are the functions and what are the pathways and what are the genes I have to be talking about. They will be regarding cell cycle, some homocysteine metabolism, angiogenesis, glucose metabolism, etc. Rather PI3K, KT pathways, the inflammatory pathways, and all the genes are in the, yes, pardon?
No, sir, you can continue.
Yes, and all the genes are in the network, which I have previously shown. Next one. This randomized, then we used a filter of randomized sample modeling based on the recursive feature elimination type to reduce these high number of pathways. And ultimately, we usually get some 7 to 8 pathways, like insulin signaling, MAP kinase, cholesterol metabolism, apoptosis, and so on. Now, what pathway we usually get? We reconfirmed it, all those specific molecules by QRT-PCR and immunohistochemistry. Next slide. Next, yes. So this is the comparison of microarray with QRT-PCR with and immunohistochemistry findings. And here we can see that all those findings are completely similar. So I am not going in detail. You can just go through the molecules like CPS, BAX, caspase-9, P53, HIF1 alpha, that is hypoxia, COX2, NF kappa beta, etc., etc. But one novel thing in this pathway is the PKM2, pyruvate kinase muscle isoform 2, which is a novel molecule which we got from this microarray. And this particular molecule always gives a lactate shunt, always stimulates or rather triggers the lactate shunt in the metabolism, and thereby it gives the hypoxia effect. Next slide. Give the full slide, then it will be easier. Yes, yes. Now, for a successful viable pregnancy to occur, the balance between the pro-inflammatory and the anti-inflammatory genes or molecules or proteins is an absolute necessity. With the state of hypoxia determining the contour for the implantation along with other regulatory molecules. And whenever this balance is tilted in favor of the pro, a disaster happens. An oxidative stress mediated placental damage perhaps represents the pathogenesis of this hyperhomocysteinemia associated pregnancy loss, which was identified through potential signaling pathways like HIF1 alpha, PKM2, caspase-9, etc., etc., etc. The heat map of normalized microarray results, which I have shown, and the activation of that gives a PKM2 activation, rather PKM2 deprivation, which inhibits the glycolysis, thereby diminish AKT and increases the glucose accumulation. PKM2 diminution will also increase the lactate shunt, as I have previously mentioned, thereby stimulating the ROS function and increasing the HIF1 alpha, which we reconfirmed in the QRT-PCR and the IRC findings. Additionally, this might open the arena of the therapeutic modalities of preeclampsia or unexplained spontaneous miscarriage or hyperhomocysteinemia associated miscarriage in PKM2 development drugs in the area of pregnancy loss. And um, I expect future studies in this, in which the animal model of preeclampsia or unexplained spontaneous pregnancy loss, to verify the actual role of PKM2, especially the tetramer to dimer transition, and allow the analysis of placenta in the gestation.
Sir, can I go for last slide?
Yes, thank you.
Thank you, sir, for the very informative session and wonderful session. Hello, sir.
Yes, yes.
Sir, there are some questions from the participants. Sir.
Yes,
Shall I ask, sir?
please.
What is the effect of homocysteine on oocyte physiology?
On oocyte physiology.
Yes, sir.
Yes. Homocysteine is an amino acid, and as I mentioned in my talk, that many of the women, around 60% of the women, be they are PCO or non-PCO in India, they are hyperhomocysteinemia. And the main follicular growth for a woman depends on her oocyte. The effect of homocysteine on the oocyte starts from the activation of the embryonic genome, as more of homocysteine will induce all the apoptotic cascade and will diminish the oocyte potential to mature the oocyte itself.
Okay, sir. And another question, sir. Is there any method to detect early termination of pregnancy?
I couldn't get your question. Is there any
Are there
method to detect?
early termination of pregnancy?
Well, this is a purely clinical question, and I am
Yes,
not a
sir.
clinician. And I am not a
Get it.
clinician.
Thank you, sir. Thank you for the wonderful session, sir. And here are some of the feedback from the participants here.
Okay. What?
I'm just displaying the feedback for you, sir.
You can see on the screen, sir.
Oh, okay. Oh, yes, yes. Thank you.
Thank you, sir. Thank you so much.
Thank you.
Dear participants, e-poster video presentation is being organized as a part of this e-conference, and nearly 25 presentations are there. And the evaluation has been completed, and here are the winners. And the first prize goes to Steffi Bennis from St. Joseph College of Pharmacy, Kerala, and the topic is lymph disease and overview. Steffi Bennis. And the second prize goes to Tejashwini Vasireddy from Mallareddy Institute of Pharmaceutical Sciences, Hyderabad. And the topic is case analysis of a patient with hepatitis C induced liver cirrhosis. And the third prize goes to Shubhadeep from School of Pharmacy, West Bengal. And the topic is a review on phytochemical and pharmacological activity of remarkable plant, that is the wonderful tree. And there is another more prize, that is third prize again, to Miss Jyotirmay from VV Institute of Pharmaceutical Sciences. And the topic is molecular docking, approaches, types, applications, and basic challenges. And from the team of e-conference on alternative to animal experimentation in pharmacology, I congratulate all the prize winners. Now I request convener Professor A. Lakshman Rao sir to give summary on this e-conference. Over to Lakshman sir.
Eminent speaker of today's session, Dr. Pradeep Chakravarti Garu, coordinator for the e-conference program, Dr. Sheikh Aminabi Garu, participants from various pharmacy colleges, both faculty, fraternity, and student community from various colleges. A very good afternoon to one and all, and a warm welcome to all of you for the valedictory function of today National E-Conference on Alternatives to Animal Experimentation in Pharmacology, organized by VV Institute of Department of Pharmacology, VV Institute of Pharmaceutical Sciences, Gudlavaleru, in association with Acharya Nagarjuna University College of Pharmaceutical Sciences, Nagarjuna Nagar, Andhra Pradesh. And on behalf of VV Institute of Pharmaceutical Sciences, my foremost gratitude to Acharya Nagarjuna University authorities for association with us to conduct online e-conference, and especially Professor A. Pramila Rai, convener and principal, College of Pharmaceutical Sciences, Acharya Nagarjuna University, Nagarjuna Nagar, for her kind support in organizing this e-conference. My heartfelt gratitude to the resource persons, Dr. Madhav N. Mugale, speaker for day 1, and Dr. Pradeep Chakrabarti, speaker for day 2, for their excellent deliberations. And I especially congratulate the prize winners of e-poster competition, and also congratulations to all the participants for the active participation in e-poster competition. And let me thank the Journal of Interdisciplinary Cycle Research authorities for association with us by publishing the e-conference proceedings as well as full-length articles in AICT, that is UGC approved careless journal, that is Journal of Interdisciplinary Cycle Research. My heartfelt acknowledgements to the members of management of VV Institute of Pharmaceutical Sciences and AIM and VVRSR Gudlavaleru Education Society, Dr. V. Nageshwara Rao Garu, Chairman, Sri M. Srinivasa Rao Garu, Co-Chairman, Sri V. Satyanarayana Rao Garu, Secretary and Correspondent, Sri V. Ramakrishna Garu, Co-Secretary and Correspondent, for their generous and continuous support in making the event a grand success. And let me congratulate Dr. Sheikh Aminabi, Coordinator and Head Department of Pharmacology, for her interest and enthusiasm for organizing this wonderful online e-conference. And I thank Ms. A. Saidatri, Assistant Professor, for providing us the technical support for this particular program. I thank all my teaching and non-teaching staff members of VV Institute of Pharmaceutical Sciences, Gudlavaleru, for their active involvement in the successful completion of this event. I especially thank principals of various pharmacy colleges for their support and registrations made by the students and staff. I thank all the participants, and I especially thank all the people who are invited or involved and directly or indirectly for making the two-day national e-conference in a very grand success. Finally, I thank each and every participants for their keen interest for upgrading their knowledge in the participating e-conference. And finally, thank you one and all, and have a great day. Stay safe and stay happy and stay healthy. Wish you good luck and all the best. And over to Dr. Amina Bigalu.
Thank you, sir. Now, there is a small announcement for the participants. The feedback link is available in the description tool of YouTube, and the link will be active only up to 4 p.m. today. Those who have filled the feedback will get the e-certificate. Thank you, sir. Thank you to all the participants. Let us end this e-conference with national anthem.
अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उज्जल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Thank you, Pradeep sir. Thank you, Lakshman Rose. I'm ending up the meeting. All the participants, the feedback link is available in the description tool of YouTube, and this will be active up to 4 p.m. today. The participants who have filled up feedback form, we get a listen. Thank you all. Stay safe.
Easy అన్న అయిపోయింది ఈజీ అయిపోయింది